Okay. Please thought I did. What's going on here? I'll be with you guys now. There's always something that has to go wrong somewhere. Yes, hold on. There we go. But now, why does it keep flashing? Let's see, what happened to the other one? Still flashing. Okay, let me see if I can please start Irium. But I did. Hold on. Alright. Now I need to swap this thing around so that you guys can see what's happening. Cool. Let's check if everyone can read this. Let's do this. Okay, so once we get confirmation that we have everything the right way, then we can start with the first lot of questions. Got a squeaky window. Let's just do this as well. Okay. There we go. And okay. Got some fresh air in here. Let's just wait a bit. I'm a few minutes early, so okay. Let's see if I swap to the other camera now. If it's still going to tell me that it's going to flash the whole time. Let's have a look. So I'm going to close that, I'm going to close that, and then we'll open this. And then let's see if I go, yeah. Hey, you guys can see me. Okay, I look funny. Let me see if I make this full screen, if we can fix this quickly. That should be better. I'm not going to look so, so. If I do that one. No, then you're looking up my nostrils again. So yeah. Nope. Let's go this one. No, okay, I think we'll just keep to right. This one. Okay, let me know if you can read this, if you can, or if it's backwards. If it is backwards, then please just let me know, so I can fix it on my side. And then I'll give it another minute, and then we'll start with some questions. Have a look. Okay, welcome everyone. Unfortunately, if I change to the other camera, then I look all a bit lopsided. So if I change here, oh, there we go. That's better. Earlier on, you were looking like right up my nostrils. Okay. Let me know how the preparation's going for your guys' paper. How are you guys feeling for those of you that are writing tomorrow? Let me know how you're feeling for paper one, and then how's it going with the studies for paper two as well. So I'm going to be starting with 2022 Eastern Cape Maths paper one. So I'm actually put that link in the chat here, then you guys can access the papers as well. So those of you who want, it's this one up here. Copy and paste. There we go. Okay, so I've put the link in there as well. So any of you want to go and get the paper, I'm doing the Eastern Cape paper. Okay. All right, so I think we've waited long enough. See, we've got 3 people that have joined at the moment. Hopefully that picks up. So I'm going to get started. So I think just some warm up. I know some people asked for financial maths. Other people asked for. There we go. Okay. Others asked for some calculus, so we'll get to that as well. Please just let me know if you can read this or if it's back to front. So do I need to swap the camera around? If someone could just let me know about that before we get started. Otherwise, you guys are going to be attempting to read everything backwards today. Okay. And then let me know if it is clear as well. Can try and change the. There we go. There, the clarity should be slightly better now as well. Okay. All right. So let's get started. I see all of you. The most watched video at this point in time seems to be algebra, and I always thought that everyone would be quite comfortable with algebra. So I'm going to start with question 1. As I said, I'm doing the Eastern Cape 2022 June paper. So anyone who wants to follow along with the paper or download it, anything like that, you guys are more welcome to. I'm going to be doing question 1. Okay, so let's have a look. Question 1 is going to be algebra. I'm going to ask you to, can you please help me with this algebraic expression? Given that 3a equals 21b and 7 to the power c equals 21b, show that b equals ac of a plus. Okay, all right, we can start with that before I jump into any other one. Okay, so it says given, so by the looks here, we've got 3 to the power of a equals 21 to the power of b. Okay. And then they've also given you that 7 to the power of c equals 21 to the power of so 21 to the power of b. Okay. All right. So whenever you're dealing with exponents, okay, so just a rule of thumb. Whenever you're dealing with exponents, okay, the key thing is always find prime factors. Or your prime factors. Okay, so if we look at number 1, okay, I'm going to rewrite number 1. Okay, so we know 3 to the power of a equals to b, but the 21 can be broken down into 3 times 7, 14, 20. Yes, there we go. So we've got 3 to the a equals 3 times that. Okay. So we've got this over here. What we could do is if you divide both sides by 3, then what you'll end up here with is divide by 3, divide 3. So therefore you end up with 3 to the power of a minus 1 equals 7b. Okay. And what else do we have here? We have 7c equals to 21b. Again, around with that, so 7c equals 3 times 7 power of b. Okay. And then we could divide both sides by 7. Okay. Divide by 7, divide 7 over there. Okay, same as dividing here by 7. Okay, so we could look at that. We have to get to that b equals to a times c over a plus c. Okay, all right, which means we need to equate them. So we've got three equations or 3 unknowns, and we've got 2 equations. Backwards. Sorry, let me fix that. I thought it was. Okay, now it should be fine. So we've got only 2 equations and we've got 3 unknowns. So we're going to end up with an expression of something of the other 2 variables, okay, because we've got 3 unknowns. So let's have a look there. Okay, so if we've got that, we've got 7c minus 1 equals to 3 to the power of b. Okay. Now let's have a look here. We need to equate things together. So we know that 3a equal the 3. Oh yeah, 3a minus 1 equals 7b, and then we have 3c minus 1 equals to 3b. Let's have a look there. That's quite an interesting question. Okay. So let's see how else we can play around with that. I keep remembering I have to go that way because everything's backwards for me now. All right. So we've broken everything down into our prime factors. What's our rules for exponents? That if we have, let's have a look here. I'm working over here. If we keep with that one over there, we divide out by 3, the 3's and the 3's cancel, so we end up with that. So we end up with these 2 expressions over here. But now we need to find a way to equate them because their bases aren't the same. Okay, let's try this. Okay, 3 to the power of a minus 21 b equals 0. Okay, which means we now have 3 to the power of a minus, let's see, that's 3 times 7 to the power of b. Okay, let's see what's the exponent rules there. I just want to check something. Okay, and I have times 7. Okay, so remember you can now distribute it as well. So it could be 3a minus 3b times 7b equals 0. I mean, yeah, you could have done that here as well, which means this would actually be, okay, restart here quickly. Okay, so we have 3 to the a equals 1b. Okay, sometimes these things take me a while. So once we've got that, we can notice a equals to 3 times 7 to the power of b. So 3a equals 3b times 7b. So if you divide, I'm going to divide the side by 3b. So therefore we're going to get 3a over 3b equals to 7b. Okay. This is going to work better, which means we now have the following. We have 3a minus b equals to 7b. Okay, so that's from the first one. From the second one, we end up with 7c equals 21b. So now 7c equals to 3 times 7b. Okay, and then what do we end up with over here? We end up with 7c equals to 3b 7. Yeah, so we've got that over there. Now, the thing is, if I divide this side by 7b, okay, so if we write it like this, 7c minus b, I'm just skipping steps, equals to 3b, I have no way of equating the two equations to each other. But if I write it as such, where I have that 7b equals 7c divided by 3b, then I can equate these two equations together, which means I then have 3a minus b, okay, equals to 7c over 3b. Okay, but that doesn't really help us either, because then what's the issue here? If I multiply this by 3b and I multiply this here by 3b, I'm going to get 3a equals 7c. You sure that's all they gave you? Given that 3 to the power of a equals 21 to the power of b, and 7 to the power of c equals 21 to the power of b. Okay, so all we've done here is we've equated from what we've started with over here. So we know that 3a equals 7c. Okay, so we've done the long way around of doing that. Show that b equals ac divided by a plus c. Okay. It stumped me. It's not the first time I've had a question like this stump me, I'm not even gonna lie. 7's prime, so it stays as is. 21b stays as that. Okay, alright. Let me think about the question. Because I seem to be stuck at the moment. I don't blame you for being stuck too. Okay, being caught off guard, yeah. Let me have a think about the question, and then we'll come back to it in a couple of minutes. Let me have a look at some of the other algebra here. That's actually quite a lack question. Okay, so let me do one or two of the other questions, and then we'll come back and play around with this one. Ah, come on. Okay, so let's look quickly. 7. Okay, I'll come back to that question. I won't forget it, don't worry. I've made a note of it. Okay, so I just want to run over question 1 quickly, because I know that the formula or the format stays pretty much the same. Factorize the first one. Okay. I can see a mistake that a lot of people would make with this question already. Okay, so given you have x squared equals minus 4x. Okay, so what's the first thing most people do? Let's see. Cancel out an x on both sides. X equals minus 4. Okay. Does that work? No, because we need 2. Okay, so how should we actually do this? We should say x squared. Okay, so no. Okay, so x squared plus 4x equals 0. Now factor out the x. X, therefore x plus 4 equals 0. Okay, so therefore you then end up with x equal to 0 or x equals minus 4. And we can see, does that work? Minus 4 squared gives you 16. Minus 4 times minus 4 is 16. So yes, that's true. If I plug in 0 and 0, that works. Okay, all right. So don't just cancel out an x on both sides, because you're forgetting x equals to 0 as well. Okay, all right. Then the next one, you have to use quadratic formula. So they give you this over here, x squared plus x minus 1 equals 0. Okay, have to use quadratic formula, so x equals negative b plus minus the square root of b squared minus 4ac. Sorry. Okay, looking at the comments there. Yes, I tried doing it, but I got stuck. Okay, all right. Let me have a think about the question, and then I'll come back to yours. I've got it here. So circle it. I won't forget that. Okay, we will do it before the stream ends tonight. Okay, so going back to what we were dealing with over here, we're doing 1.1.2. It's always going to be the same setup. You're going to factorize, then you're going to use quadratic formula. Okay, that's all over 2a. Okay, and then all you do is you substitute your values in there. So b is negative, always plus 1. Okay, plus minus the square root of 1 squared minus 4. A is 1, C is negative 1. Okay, so this is a really simple one over there. Okay, and then all you do is you plug it into your calculator. Okay, so functions, fraction, negative 1. Let's do the whole thing properly. Let's do plus the square root of 1 squared minus 4, 1, negative 1. Note that this only works if you can't have, in this case, the C value also being a positive. The reason why you can't have that is because then this minus 4 times 1 times C value over here is positive, and 1 minus 4 is obviously going to give you a negative, and we can't end up with the negative under the square root. So this number here needs to be a negative so that all of this works, or we need that A needs to be negative if C is positive. Okay, and then that's all over 2 times 1. Okay, and if we then push equals, you get negative 1 plus root 5 all over 2 as x1. And then if you change that, don't forget to do the other one as well. Change that to a minus. We then get minus, plus. I'm going to change that to minus. We then get minus 1 plus root 5 over 2. So why do I get the same thing? Plus, let's see. Oh, we get the same thing, which means what? We end up getting the same thing, okay? For both x values, we know that it turns exactly on the line. Yeah, so drawing's not to scale because it needs to cut the axis. What it should actually look like is something like that. Okay, well, that's 1, okay? But if you get 2 of the exact same values, it means that it cuts the turning point is on the axis. Okay, all right, so that's that. I think I'm going to do the more difficult ones. Those are quite straightforward. So I think let's have a look at 1.1.3. Okay, that's quite a nice question. And then we'll do inequalities. Okay, everyone loves inequalities. Okay, so 1.1.3. Okay, we're doing the square root of x plus 4 minus 4 over the square root of x minus 2 equals 0. Okay. Keep shifting it too far to the other side. Okay, so if we go and we solve that, okay, we need to get rid of the square roots. Now I can't just, I suppose you could square this whole thing. But let's have a look if we do this. Take the square root of x plus 4 equals 4 over the square root of x minus 2. So now what we're going to do is multiply both sides by the square root of x minus 2. We multiply this side by the square root of x minus 2. The reason why I do that is because when you multiply with square roots, the nice thing is you can put them under the same root. So what do we get? We get square root of x minus 2 multiplied by x plus 4. Okay, equals to 4. Get rid of the square root. We square both sides. So therefore we end up with x minus 2, x plus 4 equals 16. Okay, now we can FOIL out, so that's x squared minus 2x plus 4x is going to give you plus 2x, and then that gives you minus 8 equals 16. Take the 16 over, x squared plus 2x, that becomes minus 24 equals. Okay, now we can solve. Let's have a look there. Factors of 24, which will give us 2, is 2 or 12 times 2, 6 times 4. So 6 and 4 will work. Okay, so therefore x 6, 12, 18, 24. Yeah, just making sure. X equals 0. Okay, so the larger number is going to take the positive. Why? Because this 2 is positive, so it's going to be plus 6 minus 4. So therefore, x equals negative 6, or x equals to 4. Okay, but because it's a square root, we have to check whether this actually works. And we can see already, because x equals to negative 6, let's have a look at negative 6 plus 4 minus 4 over square root of negative 6 minus 2. Aha, this is a no. Okay, so not applicable, can't use negative 6. The only one we can use is 4. Okay, why? Because if you have negative 6 over here, it's minus 6 minus 2 gives you negative 8, and we can't have a negative under the square root. Okay, all right, then let's have a look at the inequality. If we have a look at the inequality over there, pretty straightforward inequality. Okay, we're going to find the critical points. So 1.1.4. Let's find those critical points. We have x plus 2 and then minus 3x plus 1 greater. Remember, it's strictly greater than 0. Okay. So our critical points is x equals negative 2 or x equals 1 over 3. Okay, so if you plot this, remember, as I've always said, you can't solve inequalities without drawing a graph. Okay, let's see, we know it's a negative function because x times negative 3x is going to give you a sad parabola. So this is negative 2. That's 1 over 3 over there. Okay, it's not drawn to scale. And all they're asking, where is this function greater than 0? So where is it lying above the x-axis? Okay, so that's what this is asking. Where is the function above the x-axis? And we can see it's between those two numbers. So x is an element of negative 2 to 1 over 3. Okay, please don't solve the inequality with, or solve this with the inequality sign. Please don't do that because, I don't know, then you get told you must add negative somewhere and it doesn't make sense. Okay, all right. Then must I do simultaneous equations? Does anyone want me to do simultaneous equations? Does anyone struggle with that? Or can I move on to the level 4 question? Let me know. Okay, so I'm gonna skip the simultaneous equations. Okay, just remember with simultaneous equations, always take the simplest equation. So in a sense, this one over here, and make it your subject. So we can see y is on its own. So make it your subject. So y equals to 2x plus 3. Then substitute this into wherever you see y, factor out, do all that, and then solve for x and solve for y. Okay, I want to have a look at 1.3 because it is the more difficult question. Okay. So it's normally your level 4, level 5 questions. Okay, I do apologize for this line here. I am sorting out my light system at the moment. Okay, so let's have a look here. We have 1.3. Okay, we have 9x squared minus 12 px equals to minus 4. Let's just do this. Okay, so that will be minus 4p squared. Okay. So what they ask you is, given that, for which values of p will the equation have equal roots? Okay, so remember, when do we have equal roots? When the roots are equal, it means the turning point sits on that function over there. Okay, so first of all, we need to have equal roots. Okay, so we know that they are real roots. Okay, so let's have a look. We know we're dealing with quadratic formulas somewhere here. So I'm just going to rewrite this as 9x squared minus 12 px equals to, not equals, plus 4p squared. Okay, so we need x1 will equal x2, which means quadratic formula, we have negative b, okay, plus, so for x1, I'm going to do this on x1. x1 is going to be plus, so the square root of b squared. Sorry, it's completely off screen. Okay, you guys need to let me know if it's off screen, otherwise I'm going to go all over the place. Okay, so for x1, minus 4ac all over 2a. That's got to equal to negative b minus the square root of b squared minus 4ac all over 2a. Okay, now let's substitute in what everything is. Okay, remember we're solving for p, so p has to arrive here somewhere. Okay, so it's going to be negative 12p plus the square root of negative 12p squared minus 4 times 9. Okay, and then this is going to be 4p squared. Okay, let's just have a look here. Take that over, becomes positive. There we go. Okay, and then that's all over 2 times 9. Okay, and that's now got to equal this side. So it's going to be minus 12p, sorry. Then that's minus the square root, now this whole thing again. Minus 12p squared minus 4 times 9, 4p squared, all over 2 times 9. Now, because 2 times 9 is at the bottom on both sides of the equation, we're going to cancel those out, and I'm going to cancel out this negative in front, okay, because it's negative on both sides. So let's see, what do we have left here? We have minus 12p plus square root. Okay, let's see, that becomes 144p squared minus 4 times 9. Let's see, 4 times 9 gives you 36. Times 4 again. Okay, 36 times 4 is 144. 144p squared. Okay, and then that's going to equal as well on this side. That's minus 12p. Now minus the square root of 144p squared minus 144p squared. Let's see. 4 times 4. 4 times 4 times 9. That's 144. Okay. So what do we end up with here? Okay. Well, if I take this over, we can see that we're going to end up with minus 12p plus 12p. Okay. So those are going to cancel out. And then if you take this over, we're going to have the square root of 144p squared minus 144p squared plus the square root of 144p squared minus 144p squared equals 0. Okay, but what do we end up with now? We end up with this and that cancelling out, and then that minus that. So this and that cancels out. So we end up with 0 equals to 0. Okay, so that doesn't make sense at all. Okay, let's see if I missed anything anyway. Which values of p will this be? Okay, what have I butchered here? Okay, so we said that x1 must equal to x2. Okay, we took that over, that became a plus, that was equal to that. We had p squared over there. Let's see, that's p squared. So by the looks of it, we end up with 0 equals to 0. Now, because we end up with that, from what I know and how I've always done algebra, We know that x can be an element of any real number. Let me just double check here that I'm not going mad. Let's see, what have I messed up here? Okay, we did that. There we go. Okay, so I'm not going mad. If you ever end up with an answer, okay, where 0 equals 0, it's the same as saying 1 equals 1, okay, 5 equals 5. It means that no matter what number you plug in here, this expression is always going to hold. Why? Because everything cancels out. So regardless of what p is, p could be a trillion in this case. If you plug a trillion into p's place here, everything's always going to cancel out. So therefore, the answer is just x is an element of real numbers. Because it is 9, 12, and 4, it's plus. Remember, this is a plus over here. Okay, we've shifted the whole thing up 4 units. So regardless of what p is, we can make p 3. This is still going to shift up accordingly. And because there's a p here as well, it keeps it in line. So no matter what happens, our function is always, even if it does something like this, okay, it is always going to cut the x-axis at 1 point, which means x1 equals x2. Yeah. So I'm not going mad. Sorry about the buzzing. Let me just see if I can turn that off quickly. Okay, there we go. So, as I was saying, if it's ever 0 equals to 0, okay, it's got infinitely many solutions. That's what we call it. Okay, so we say it's got infinite many solutions, therefore x can be an element of any real number. Okay, all right, and then that's question 1. So let's go back to this in here quickly. I just want to have a look and see what's happening. What if we do this? What if we say 3a over 7c equals 21b over 21b? So we divide the equations by each other. And then we're just going to get 3a over 7c equals 1. That doesn't work either. This one's really tricky, I'm not even going to lie. So we have 3a equals to 7c, which means we have that 3a equals 7c, which means we have 3a equals... Doesn't make a difference. We have to go somewhere from here. And even if we write it equal to 0, we can't take out a 3 because then we have 3a minus 3b times 7b equals 0. We can't take 3 out as a common factor because they don't have the same bases. But we could equate it. So we could have 3a minus 3b times 7b. It's going to give me the same thing. I can see that happening now. Equals 7c minus 3c. Can I focus the camera? Okay, let me try. Is that a little bit better? Let me know if that's a little bit better with the camera. Okay. So we're trying to figure out this question over here. that's there, then we got to get that B equals to it's AC over A plus C. Which means we need to be able to drop our exponents somewhere, our bases, in order to get that. Probably got something to do with let 3a or let something equal to this, and then you solve it that way and so on. Because you end up with this here, 7b, which means, yeah, that just cancels out, that's all. This one's really stuck me. Okay, all right. Let's just move on. I want to go on to, let's see, where's the rest of my paper here? There we go. Okay, so question 1 we've gone through. All right, I wanted to go over some. Anyone want to do derivatives? Let me know if you want to do derivatives. Otherwise, I'm going to do financial maths. So quickly let me know in the chat, derivatives or financial maths, because those were the other questions that I had or people asked me to do in the live stream. Just double check this question and make sure that there isn't anything else added to it. Okay, so financial. Okay, let's have a look at financial maths. Okay, so I'm still doing the Eastern Cape June 2022 paper, for those of you that are interested. Okay, so over here, I'm doing question 6. Okay, so question 6 is going to be financial maths. So it says over here, I'll just fold this in half and get a new clean page to work on. Okay, so it says, question 6. Let's just move this up. Okay, so it says, how long? I'll read it here because I see it's a bit small. Let me lift it up here. There we go. That should be better to read. Okay, so it says, how long is the 50,000 investment? In how long will the 50,000 to be invested in order to double at an interest rate of 8.5% per annum on a straight line method? Give your answer in years or months. Okay, so in a straight line method, okay, as far as I understand, that is then given as simple interest. So let's just double check. Yeah, that's just simple interest. So straight line just means simple interest. Okay, why? If we look at the formula for simple interest, it's A equals P 1 plus I times N. Okay, and if you factorize that in, you then get P plus Pi times N, where N is the value changing. This is your y-intercept. So this looks the same as y equals to mx plus c. That's why it's a straight line. Okay. Anyway, just some insight there. So they've given us the investment, 50,000. We need to double it. Okay, at 8.5% per annum. Okay, so we have A needs to equal 100,000. 100,000 Rand. Okay, then we're going to go this way. Sorry, P is then given as 50,000. Okay, my interest is 8.5% per annum. Per annum. Okay, which means we convert that to 0.085. Okay, and then we plug everything in, solve for n. So it's 100,000 There we go, equals to 50,000. 1 plus my interest, 0.085 times n. Okay, and now we're just solving for n. So we're going to end up with 100,000 divided by 50,000 is 2, equals to 1 plus 0.085n. Okay, so take the 1 over, so it's 1 equals 0.085n. Therefore, n, we've got to divide 1 by 0.085, so 1 divided by 0.085 gives me 11.78. Sorry, not 78, oh, 876. Okay, so therefore it's going to take me 11 years. Okay, and then we've got to work out this 0.6, okay, or 76. So what I'm going to do is I'm going to say 0.76 times 12. That's going to be 9.12 months. Okay, so that's going to be n equals to 11 years and 9 months. Okay, all right. It's quite a long time to double your money if you're working on simple interest. Okay, now the next one says, okay, let's just have a look here. There we go. So it says a cell phone valued at 24,000, okay, depreciates at 18% per annum on a reduced balance method. Determine the value of the cell phone after 3 years. Okay, so reduced balance method. Okay, that was 6.1. We're on 6.2. Okay, so reduced balance method is then going to be compound interest. So A equals P1 depreciating minus I to the power of n. Okay, so this is reduced, reducing balance method. Okay, so it's reducing at quite a rate because it's exponential. Okay, so the cell phone's value is 24,000. Okay, depreciates at 18% on the reduced balance method. The value of the cell phone after 3 years. Okay, so we start with 24,000. So P equals 24,000. A we want to find. Okay, I we have it as 18%. Okay, which is 0.18, and then that's 3 years. Okay, so that is then given as n equals to 3. Okay, so all we do is plug it into the formula. A equals 24,000. Okay, 1 minus my interest, 0.18 to the power of 3. Okay, so now I just plug that into the calculator. 24,000, open bracket, 1 minus 0.18, all to the power of 3. Okay, so after 3 years, the phone's only valued at 13,232.83 Rand. Okay, now the next question over there. Okay, we'll go to derivatives now. Let's just finish up with this last one here. Okay, so it says X Rand is invested into account at an interest rate of 12% per annum, compounded monthly. 3 years later, 2x is deposited into the same account. After 7 years, there is 276,558.75 cents in the account. Determine how much money was invested at the beginning. That is the value of x. Okay, all right, so what do we have there? Okay, let's just write down everything we have. Okay, so they gave us that we start off with, so if we draw a timeline, okay, we start and we invest X amount, okay, that is at 12%, okay, compounded monthly, okay, so therefore n is going to have to be multiplied by a number of months, and your interest must be divided by 12, and then n times 12, okay. 3 years later. So now we go plus 3 years. Okay, we now put in 2x into it. Okay, still at the same interest rate. Okay, and then 7 years later, or after 7 years, so plus 4 years. Okay, now we're sitting at 7 years. We have this total of our 2,000 or 276,258.75. Yeah. So we've got to find x. So at least we have everything. So what we have to do is we have to expand our formula of a equals p1 plus I times n, not times n, to the power of n. Yeah. Now, this is going to be for the first 3 years. Yeah. Then what do? We add in. Okay. So then it is plus, again, p1 plus I to the power of n. And this is now going to sit for how many years? This year, this is not sitting for 3 years. This is sitting for the full 7 years. This part here is sitting for 4 years. Okay. So let's plug everything in here. The first thing is x. Okay. Yes. X times your 1 plus your interest. We're just using this formula, sorry. Times your interest. That's 12% divided by 12. Okay, why? Because it's compounded monthly. Okay, and then it's sitting there for 7 years. So 7 times 12 is going to give you 84. Okay, now plus 2x. That's going to be sitting there, 1 plus 12 divided by 12. Okay, so it's 12%. We remember to convert it. Don't just stick 12 into the calculator here because you're going to get 1 and then you're going to end up with 2 here, and then it's just going to be a disaster. Okay, and then this is going to then be sitting for 4 years, so that's 48 months. Okay, and we know the total. The total was 276558.75. Okay, all right, so what do we actually have here? We can take out x as a common factor. And then we have 1 plus 0.12 divided by 12 to the power of 84, plus 2, 1 plus 0.12, okay, all over 12 to the power of 48. Okay, and then we still have 276,558.75 over there. So we're dividing that by this whole bracket here. Just punch that into your calculator. Okay, so let's have a look there. We have 276,558.75. That's going to be all over open bracket again, 1 plus 0.12 divided by 12, close bracket, that's the power of 84, plus 2 times open bracket, 1 plus 0.12, all over 12, and that's the power of 48, now times 48 to the power of 48, and then close bracket, and we get that x equals to 64,361.95 rand. Okay. Let's just check. What's this value that they gave us? It was 276,558.75. Yes, there we go. And we have everything else here. Okay, so just remember that this one sat for 7 years. Okay, the full 7 years. This one only sat for 4 years. Okay, so even though they said for the first 3 years this one's gaining interest, don't forget that this sits for the full 7 years. So don't use the 3 years. Okay, use the full 7 years on that first amount. Okay, all right. Sorry about that. Is the camera focused? Yes. Okay, so financial math. The other one that often confuses people is future value formula and present value formula. Okay, if you want to know what your investment's going to be down the line, okay, or if you want to know what the value of piece of equipment is going to be or something like that, you use future value formula. If you want to know what it's going to be now, hence present value formula, you then use the present value formula. Okay, and all of that is on your formula sheet. Let me just check if I have a formula sheet. I do. Okay, so future value formula is over here. The difference between the two is present value, you start off with a negative, or you're paying back. Okay, so that's why n is negative, because you've taken the amount and now you've got to pay back those months until you get to 0. Whereas future value, okay, it's your interest bracket minus 1 divided by your interest, where it's 1 minus your interest bracket, and your interest bracket's to the power of negative n. Okay, so therefore you've got to pay that money back. Okay, all right. Let's then do calculus. Actually, my favorite section. So let's have a look at question 7 over here. Okay, so question 7 over there says determine f prime of x from first principles if f of x equals negative 2x squared plus x. Okay, so first principle, we are dealing with the following formula. F prime of x. Okay, this is question 7. F prime of x equals the limit as h tends to 0 of f of x plus h, okay, minus f of x all over h. Why this formula? Where does it come from? Well, let's have a look here. We all know what gradient is. Okay, we know that gradient m equals change in y over change in x. So if we look at an arbitrary function, okay, in this case, the one that they've given us is a parabola of some sorts. Okay, now if we want the gradient, we've got to take 2 points like such, okay, in order to find the change in y and the change in x. Okay, what's happening here is we are calling this, okay, this is our starting value, x. Then we move a little bit down the line and we've added how many units on? We've added h units to get to this point here. So this is x and y. This is x plus h, and we've shifted up now in our y as well. Okay, yeah, and then we're going to end up with y2 over here. Okay, but remember, y1 and y2 can be represented as the function. Remember that. Y equals f of x. So this is just going to be equal y2, moving down the line, moving along your function, is equal to f of x plus h, because that's what the x value is, so you'd substitute that in there. Okay, then over here you still have just f of x, because that's what you started with. Okay, so we've sorted out the change in y. So we have y2 minus y1. Okay, so f of x plus h. Okay, we've moved h units down, minus f of x. Now, where does this h come from? Okay, well, that's this distance here. Okay, so that is the distance on the x-axis. So it's the change in x. So it is x final, x plus h, minus x initial, which is just x, which then gives you f of x plus h minus f of x divided x and x cancel by h. That's where it comes from. Now, what is limit? Limit just says if I make this gap small and small and smaller, okay, so if I start moving these points closer towards each other, okay, what's going to happen to this function? That's where we get the gradient, because then we end up creating a tangent when x gets extremely small. Now, I can't just substitute 0 in here because I'm not allowed to divide by 0, so we've got to get rid of this h in some way, and that's why we use first principles. Okay, so let's have a look. Our function they gave us was negative 2x squared plus x. Okay, So this is just a fancy way of writing gradient as your change in x becomes really, really small. So as it comes to a point, this is just a fancy way of writing gradient. Okay, so that's our function. So let's do this. Everywhere we see an x, we plug in x plus h. So I'm going to write again, the limit h tends to 0 of negative 2x plus h squared plus x plus h. Okay. Now we minus off the original function. Minus 2x squared plus x. Okay. And that's all divided by h. Now, FOIL everything out. I'm just going to write this here. The limit as h tends to 0. Okay. And then what do we get? At the top here, we're going to get minus 2x squared plus 2xh plus h squared. And then we're left with plus x plus h. Distribute that in there. Plus 2x squared minus x. Okay, so we can already see this, and that cancels out. Okay. We can see if we distribute the negative 2 in, we can see we're going to end up with this. Negative 2x squared minus 4xh minus h squared, and then we add here plus h plus 2x squared all over h. So you can see that, and that cancels out. We need to cancel out that in the original function. So you need to cancel out this term. Okay, canceled that out over there. Now we're just left with this over here. Okay, so we're going to take out h as a common factor. Okay, so what are we going to be left with? We're going to have h minus 4x minus h plus 1 all over h. Now your h's cancel, so now you have the limit as h tends to 0 of minus 4x minus h plus 1. Okay, now you can substitute h equal to 0 into here. That's allowed. Okay, which then means we just end up with minus 4x plus 1. And if you go and do the shorthand or the shortcut method to find the derivative here, you'll end up getting 2 times negative 2 is negative 4, 2 minus 1, x, and then 1 times 1 is 1, 1 minus 1 is 0, and then you just end up with plus 1 over there. Okay. All right, so first principles, 5 marks. Okay. It's actually really nice. Once you understand how it works, okay, it's actually really cool. Then you're not just memorizing things. Okay, so the next thing is determine the derivatives of the following. Okay, they're always going to give it to you like this. Okay, 9 out of 10 times you're going to get one that looks like this one over here, where they give you capital D underscore x, and then they give you the function. It's the exact same as writing the derivative. Okay, so dx equals dx. It's the exact same thing. Okay, and then we're doing that for negative 5x over square root of x minus x squared over 5. Okay, whenever you get something complicated like this, because you guys haven't learned any other derivative rules, unless you've done AP Maths, but if you haven't learned any other derivative rules, then you always get this into simple exponent form. So don't end up with x's at the bottom or anything like that. Okay, so let's just sort that out. dx minus 5. Okay, so this is x to the power of a half. So this can be x1 minus a half minus x squared. I'm going to write this 1 over 5. Okay, so 1 minus a half is going to give you a half. So we end up over there with dx minus 5 x to the power of a half minus 1 over 5 x squared. Now we can find the derivative. Okay, so what do? We multiply this down and we minus 1 off. Okay, so a half times negative 5 is the same as saying 2 times 5. If you, or a half time, whoa, never mind, I'm talking rubbish over here. 5, that's negative 5 over 2x. Now, a half minus 1 becomes minus a half. Okay. 2 times negative 1 over 5 is then going to become minus 2 over 5x. Now remember, we're minus 1, so you're just left with that over there. Now just rewrite it neatly. Okay, we don't like negative exponents, so it's got to go down. So this is then equal to negative 5 over 2 root x minus 2 over 5x. Okay, and that's the derivative of that one. Okay, remember, always square root of x equals x to the power of a half. Okay, why? Because that 2 right there becomes the denominator. Okay, if it was the fifth root of x, it's equal to 1x to the power of 1 over 5. Okay, all right. And then to do the last one over there. Okay, so first FOIL out, then do the derivative. Okay, so space, nope. Okay, so let's have a look there. We're doing 7.2.2. Okay, so 7.2.2, let's just wait for it to focus. There we go. So the derivative of x plus 2 over x, and then x minus 2 over x. Okay, now the nice thing is we can see the brackets are identical. Come on. Wait for it to focus. There we go. So we can see the brackets are identical over there, which means what? It's the difference of two squares. Okay, so what are we going to have? dx, and just write it out. That is x plus 2 over x, x minus 2 over x. Okay, so when you FOIL this out, you're going to end up with the difference of two squares. D over dx is then just going to be x squared minus, let's see, that times that is going to be 4 over x squared. Okay, so we're in the same boat as the previous one. Take this up, but don't have your x at the bottom. So we're going to have dx of x squared minus 4x to the power of negative 2. Now we can do the derivative of it. So that's going to be equal to 2x. So we multiply it with the number in front, minus 1, multiply minus 1. Okay, so 2 times 1 is 2. 2 minus 1 is just 1. Minus, oh, hold on, that's going to become a plus because it's negative 2 times negative 4 gives me plus 8x. Minus 1 off gives me minus 3. Okay, so if we write that, it's 2x plus 8 over x cubed. Okay, and that's the derivative of that one over there. All right, so we've got about 20 minutes left. Is there any questions, any other questions from anyone else? Anything they want me to go over, anything that they're not sure about? I'm still trying to figure out this question. Okay, so let me know in the comments but if there's any other questions that you guys want to look at. Let's play around with this. Can you please do sigma notation question? Okay, all right, yes, we can do that. So that's got to do with sequences and series. Let me find one of those quickly. So let's have a look here. So this question 2. Okay, so sigma notation. So let's just run over what sigma notation is. Okay, so when we look at sigma notation, let's do it on the page. Okay, so dealing with sigma notation, that is this here. All it means is the sum of. So you're going to end up with a function or a sequence of some form. You'll end up with I equals to from A to B. Okay, so A is the starting value. B is the end. Okay, so that's the last term. And then F is of X is your sequence. Okay. So let's have a look, for instance, here. Okay, they give us the following over there, and then they tell us to find M. Okay, so they give us this over here. Sum k equals 1 to infinity, okay, of 6m to the k minus 1 equals 12. It is backwards. How's it backwards? I haven't changed anything. Is the numbers backwards again? Does this make it better? Please emphasize more on proving the equation of a parabola graph. Okay, can I have a look at that? This way is how it's been pretty much the whole stream. So is it still backwards? Just let me know if it's still backwards. Okay, so we're going to do proving equations of a, let's make a note of that. Okay, no. So equation of parabola. Okay, I think I know what you're talking about there. So let's just go over this quickly. Okay, so whenever they give you something like this, okay, write out a few expressions so that you know what you're dealing with. Okay, so we're going to start k equal to 1. So when k equals 1, let's see, we have 6 times m to the power of 1 minus 1, which is 0. Okay, so we just have 6m 1 minus 1, which equals 6. Okay, because anything to the power of 0 is 1. Then when k equals 2, we end up with 6m to the power of 1, which equals 6m. K equals 3, we end up with 6m to the power of 3 minus 1. Okay, which then equals 6 to the m squared. So what are we noticing here? This is m to the 0. That's m, that's it. So we have a common ratio of m. M's been multiplied the entire time. Okay. So if we have a common ratio, we're dealing with a geometric sequence. Okay, and we're summing to infinity. So all you do is you go to your formula sheet. Okay, we find sequences in series. Okay, let's have a look here. So we need this one over here. Okay, we know we're summing to infinity. We have a common ratio. The common ratio is m. Let's see if they gave us any other information there. No, they didn't give us anything else about it. But the main thing was they said here that the sum to infinity equals 12. Now, because it equals 12, it means it converges. Okay, if it didn't converge and it sums up, it would just continue increasing. Okay, so what this means is we now have that it converges. So we know m sits between -1 and 1. Okay, so now we can solve for m. So we're just going to use this formula over here. Okay, the formula sum to infinity equals a over 1 minus r, which is your common ratio. Okay, so sum to infinity equals a over 1 minus, and your common ratio is m. Okay, a is always the first term in the sequence. Okay, so that, and we have this, it's 12 equals 6 over 1 minus m. Okay, so let's see, that's 12 minus 12m equals to 6. How do I get that? I took this across and then just distributed in. Therefore, we end up with 12 minus 6 equals 12m. That gives you 6 over 12 equals m. Therefore, m equals to half. Okay, and we know that a half sits between -1 and 1. So we know, therefore, it has a common ratio. So the key thing, if they give you this or they give you sigma notation, write out that first so that you know what's happening. You can see there's a common ratio. Try and find that common ratio that you're dealing with and then answer the question accordingly. Okay. Please emphasize more on proving the equation of a parabola graph. Okay, so proving a parabola. You're talking about parabola or hyperbola? Because let me know which one you're dealing with. Because a parabola is this one here. Okay, hyperbola. And then your hyperbole okay, is this one over here. This one has asymptotes, this one doesn't. Okay, so when doing a hyperbola, if they ask you, let's say they give you this here, they give you that is 3, they give you this here is minus 5, and then they say prove the equation. Okay. Is that better? Can everyone tell me, is this better or is this backwards now? So can you read this? Is this forward or is it backwards? Because I have one person telling me it's fine and then I have another person telling me it's backwards. It is backwards. Okay, but then when I changed the camera this way, you said it was backwards. So now is it fine? So tell me, is the camera fine now? Can you read? Okay, there we go. It's fine. Okay, so when proving the equation, you have your intercept. So we know that we have here the first one. We have that x equals to 3. Okay, so we know that an x-intercept is when the function or when y equals to 0. Okay, so how do we get that? Well, we've got two of these. We have x equals -5 and x equals to 3. So this can be rewritten as x minus 3 equals 0, and this is x plus 5 equals 0. Now, the combination of this needs to make up my function. So f of x equals x minus 3, x plus 5. Okay, why? Because these two, both of these need to equal to 0 to solve the intercept. So this is technically this here. Okay, because they're both equal to 0. And then all you do is you FOIL it out. So yeah, you'd end up with f of x equals, let's see, that's x squared. 5 minus 3 gives you plus 2 x, and then minus 3 times 5 is minus 15. Okay, so that's, if they ask you to prove, take what's given to you and then get to the equation they want. Okay, if it's a hyperbola that they want you to prove the equation, like the video I did, inverse and exponential. Okay, all right. So do some graphs here. Okay. With the hyperbola, let me just go over this quickly. With the hyperbola, you look for the asymptotes. Okay, So remember the equation here is f of x equals to a x plus or minus p plus or minus q. Okay, please note that q is not the y-intercept. Q is the horizontal asymptote and p is the vertical asymptote. So if they say that x does not equal to 3, then we know that x minus 3 does not equal to 0. Then we have p's value over there. So we have that p equals to minus 3. So p equals minus 3. Okay. And then what you do is you look at your range. Okay, so you go and you find your range. If they say that the range is y is an element of real numbers, but y does not equal 5, okay, or minus, 5, then you found your q value over there because you know that 5 is not included. So it's everything below 5 and everything above 5. So you know your q value is then 5. Okay. And that's how you go about proving the equations. Okay. All right. Then talking about inverse functions. Yep. Let me just do this over here. Inverse and exponential. Okay. So if you have an exponential function, which looks something like that. Okay. We want to find the inverse of the function so that we often use it in science. You find inverses or you change the scale of your graphs in order to interpret the data better. So you can change it to a logarithmic scale or something like that. Okay. So whenever we find the inverse of a function, you always reflect that function over the y equals x axis. So if I take this and fold it in half, what kind of function is that going to look like? Now, if you have f of x equals 3x, for instance, okay? The 3 in the front here just tells you how quickly we are climbing, okay? So that's sort of like how steep or how wide it is, whether the function is going to look like this, or sorry, like that, or whether it's going to take a long time to climb up. Okay, so now whenever we find the inverse of these functions, note that we never find the inverse of a parabola, okay? You guys won't do that because then you end up with a non-real function because it fails the straight line test. Okay, so you always find the inverse of exponential functions. So how do we do that? The first thing is you say let y equals x. So we know we're reflecting it over the y equals x axis. Okay, so that when we take y equals to 3x, it now becomes x equals 3y after this step. Okay, now in order to get the variables back to how it was, because they always want it in the form of y equals to something. That's how they're always going to ask it, okay? You've got to convert this to a logarithmic function because that is the inverse of an exponential function, okay? So if you reflect this over, you end up drawing a logarithmic function. How do we do that? It's called the, I do it, it's called the drop and swap. Okay, drop and swap method. So the 3 drops down and becomes the base of log. And then you swap x and y. Okay, so I'll do this in 2 steps. Not mathematically correct to say this, but x equals log of base 3 y. Now we swap x and y. So that y becomes log 3x. Okay, if they give you this here and you want to go back, then it's pop and swap. Okay, so if you go from exponential to log, it's drop and swap. If you go from log to exponential, It's pop and swap. What does that mean? If I have y equals log of 1 over 5 x, okay, and I want to find its inverse. I want to find f negative 1. Okay, also note it's not f negative 1 of x does not equal 1 over f of x. Okay, that is no, please don't do that in your exams. Okay, so if we now want to get this to an exponential, we are going to pop, so that comes up, and then we swap these. I'll do it in 2 steps again. Okay, please just don't write this in the paper because it's not mathematically sound or it's not correct, but it's just for interpretation. It's y equals 1 over 5 to the power of x, and now we swap those to, x, y. Okay, remember, because we let y equal to x. Well, let me just rewrite this whole thing. Y equals log 1 over 5 x. Okay, then say let y equals x. So then you have x equals log of 1 over 5 y. Okay, now we pop and swap. So what's happening? X equals 1 over 5 to the y. And now we swap those there. So y equals 1 over 5 x. Okay, and then that becomes, this is equal to f negative 1 of x. Okay, so that's how we do the inverse functions. All right. I think I figured out this one. Okay, let's see. Last few minutes, I think I've figured out this question. Maybe. I'm going to do some dodgy maths. Let's see. 3a equals 21b. Multiply this side by 7c. Multiply this side by 7c. So why do we do that? So then we have 7c 3a equals 3b times 7b multiplied by 7c. So it needs to be a positive. Because then what we end up with is 7c 3a equals 3b multiplied by 7b plus c. Now if we take that over, it's still not the same base. I thought the dodgy maths would save us. We know that this, 7c equals to 21b, so let's see, that would be 3b times 7b multiplied by 3a equals 3b times 7b plus c. So that's 3b plus a times 7 b equals 3b times 7b plus c. So we need a plus c. Please explain your long division of cubic functions. Oh, okay. Long division. So let's have a look at a cubic function. Let me find the cubic function quickly, and then you can do long division of that. Let me just find it on here quickly. Yeah, here we go. So I've got the following cubic function. F of x equals to x cubed minus 5x squared minus 8 x and then plus 12. Okay, so we want to do long division of this. So long division just finds our roots. Okay, so the best thing is check when you factorize this. Okay, before I jump to conclusions, when you factorize this, you need 3 brackets. You need x, x, and x. Okay, so we're going to get the first bracket by testing the following. We're going to check when x equals to -1, 0, 1, and then you check your branch out with -2, and so on and so on. Okay, so if we check -1 over here, that's going to be -1. Okay, so when x equals -1, and it's -1 cubed minus 5 times -1 squared minus 8 times -1 plus 12. Okay, so -1 minus 5 plus 8 plus 12. We know that that's not equal to 0 at all because that's already 20. Yeah, it's not going to work. Okay, let's see if we use plus 1. Okay, 1 cubed minus 5 times 1 squared minus 8 times 1 plus 12. Okay, so 1 minus 5 minus 8 plus 12. That's 13. 8 plus 5 is 13. So we end up here with minus 13 plus 13 equals 0. So because we have this equal to 0, we know that the first factor is x equals to 1, which means now that we have this, we have x minus 1 equals 0. That's your first bracket, minus 1. Now we need to find the other 2 brackets. So we do long division of this using that. So what do I mean by that? Set it up x minus 1. X cubed minus 5x squared minus 8x plus 12. Okay, so now you only deal with the x here, you don't try and put x minus 1 into x cubed. It's not going to work. So x goes into x cubed. What remains? X squared. Now x squared times x, minusing it off, x squared times x gives you x cubed. X squared times -1 gives you minus x squared. Okay, now do the subtraction of what you can here. That becomes 0. Minus 5 plus 1 becomes minus 4x squared. Now you bring this down and you bring that down. So minus 8x plus 12. Okay, now we do it again. X goes into -4x squared. What's left? Minus 4x. Now you multiply it down again. So minusing off -4x squared times x gives you minus 4x squared. Okay. Then -4x times -1 gives you plus 4x. Minus it off. We know that this will cancel because it's a negative minus a negative, so that becomes positive, so that's 0. Now, minus 8 minus 4 becomes minus 12x. Bring that 12 down, plus 12. Okay. Therefore, we do it again. X goes into minus 12x. What's left? Minus 12. Now you multiply this and that. So minus 12x. Minus 12 times minus 1 gives you plus 12. Aha! Everything cancels off here. So we know that this is what we're left with. There's no remainder or anything like that. So now we have x minus 1, and then we have what's left up here. X squared minus 4x minus 12. And we can factorize this. That's far easier to factorize. So x minus 1. Let's look at our two brackets. X and x. Factors of 12 to give us 4 is 6 and 2. Okay. One of them needs to be negative. One of them needs to be positive in order to produce this negative. So because this is negative, the larger number is going to take the negative sign. Plus 2. And therefore we have all the factors of this cubic function. Okay, so this is what f of x looks like factorized. Okay, so that's how we do that. All right, so I see we've reached the end of we've reached an hour and a half. Okay, this is going to be the end of the stream. I haven't figured out this question yet. I thought I managed to figure it out, but it still seems to be stuck here. It's probably something simple that I'm missing. I'll probably wake up in the middle of the night and figure it out. Okay, but it's a very weird question. 3 to the power of a equals 21 to the power of b. 7c 21b. Those two are equal. It means that 3 to the a equals 7 to the c. I'll see how it goes on Sunday. Regarding the live stream on Sunday, I do work over weekends. I'm a maths tutor and a science tutor, so I work pretty much the whole weekend. So I'll see how it goes because I normally end late on a Sunday. But if I do, I will put a message up on the community chat regarding doing a live stream on Sunday. I'm going to try my best to try and get all the videos out for Maths Paper 2 before you guys write on Monday. But yeah, I'm going to try my best for that. Otherwise, what I'll do is I'll do the live stream and then I'll cover those questions in the live stream so that you guys at least have everything before Monday. All right. Thanks everyone for watching. Thank you for taking part. Thanks for the questions. I need to go figure out this question, and then I will maybe post a YouTube short just explaining it. Hopefully I can get that done tonight. Otherwise I'll get it done over the weekend. So yeah. Anyway, have a good evening. Good luck with all the studies. If you are stuck with anything, check out some of the videos on my channel, and I'll see you guys around. Thanks for watching the stream.